So the next two ways that we can decide that safely that two triangles are congruent is using something called ASA and AAS congruence. So you'll notice the difference there. We have two angles and then one pair of sides that are congruent between two triangles. It has to do with the location of the side compared to the angles. So let's take a look. So first, angle, side, angle congruence. Notice that the side is between. So the side is between the two pairs of angles. So if I had a triangle where I had this angle, and let's say there's another triangle here where it's congruent to that angle, and we have this angle, that would be two pairs of angles, yes? AA. Where's the side between them? Well, it's the side formed that runs literally between those two angles. So that angle, then the side, then the angle are happening in each triangle, okay? Now this is not to be confused with angle, angle, side, which is also sometimes side, angle, angle. It doesn't matter. The key thing is you've got two angles in two different triangles that are congruent, so kind of like we started off before, except now instead of knowing the side between them, which would be this side here, it's got to be one of the other sides. Remember, it's just one pair. Now, does it matter which is which? And the answer is yes. Here's why. If I were to say that this angle, or sorry, this side was congruent to this side, we'd be okay. We have angle, angle, side, we have angle, angle, side. Here's the deal. This angle with the two, this angle here, which is congruent to this angle here, is opposite the side that is congruent, meaning angle same to side opposite, angle same to side opposite, okay? So this could be like, let's say that's a 70-degree angle and it's opposite this side, and this is another 70-degree angle opposite this side. Would that be different if we were looking at something like this? Well, here's the deal. Let's say that this is our 70-degree angle and it's opposite this, yes? And maybe 70 degrees is the largest angle there, so that's the longest side. That would mean that this is a 70-degree angle, but is this necessarily the longest side? No, because this is the same side length, but it's opposite a smaller angle. So does the order, in other words, we have this angle here, then we have another angle, then we have the side immediately after that first. Does that make a difference? Yes. Or if we have a side, then we have the angle immediately next to it, and then the next. That's where we either say angle, angle, side. So does this look the same? It almost looks right? We have two angles and then the side not between. The problem is they have to be opposite. The side must be opposite the same pair of congruent angles. This is not opposite the same angle that is congruent, to, is it? So that would mean that this does not work as side angle angle. So once again, let's take a look at some examples, and that may help. Okay, so remember, you can conclude stuff from the drawing. Like we know that this and this, now remember one arc was already taken up. These are vertical angles and therefore congruent. So can we safely say angle, then side, then angle in both cases? Yes. ASA only happens one way. Ha 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 ha. Okay, what about this? Well, we can safely conclude that this is congruent to itself. Hopefully you're seeing these, reflexive property, right? And now we've got, oops, I already used one tick mark, so we got two. Side, side, angle, side, angle. So we have side, angle, side up here, right? And we have side, side, angle, not enough info. We cannot necessarily say that they're congruent. Okay, no configuration known. What do we got here? Well, we have a shared side, so reflexive property. And remember, looks can be deceiving. Nothing else except the shared side can be safely said to be congruent. So I have an angle and I have a side, I have an angle and a side, not enough info, and done. So let's change up colors here. What are these? These are, you guessed it, vertical angles. So getting used to recognizing vertical angles and reflexive property, very important. So what do we have? angle, angle, and then the side. And please note that the side is next to the 2 arc angle. That's going to be important. Angle, angle, side. Is the side next to the 2 arc angle? Yes. So these are congruent by angle, angle, side. It's safe to say. So remember that key thing. This side is opposite the 1 arc. This side is opposite the 1 arc, which is okay. All right. Oh, this is lucky. We don't have to decide anything. So angle, side, angle. Yes, 2 angles, side in between. So these are congruent by angle, side, angle. Our friend, the reflexive property, which means what? Angle, angle, then a side, and the side is next to the 2 arc or opposite the 1 arc. Angle, angle, side, same thing. The side is opposite the 1 arc, just like here, or it's next to the 2 arc, same thing. Congruent by angle, angle, side, or side, angle, angle. All right? Look at this. Vertical angles. This is a right angle, that's a right angle. These are vertical angles. So what have we got? Well, we got an angle, we got another angle. We got an angle, we got another angle. Then we have a side. Are they in the same configuration? Yep, this side is next to the right angle. So is this one, right? It's opposite the 1 arc. So these are congruent by angle, angle, side. Yay. All right, last one, reflexive property. Hopefully you're getting the hang of that. Reflexive property, vertical angles, right? Very important. Angle, angle, then the side, angle, angle, then the side. Next to the 2 arc, next to the 2 arc. Congruent by angle, angle, side. Okay. So now, just like the last one, what we're going to look for here is what information do we need to add that's not already given in the drawing, or, right, either tick marks or, in this case, the vertical angles, right? What else do we need to add to get angle, angle, side? Okay. Angle, angle, side. So we want to have 2 angles and then the side not in between. So there's only one way to go. It's got to be this angle and this angle, right? Opposite, opposite. So we need to know that angle A is congruent to angle H. Angle, not triangle. Angle, angle, H. That's be the information that we need to add, okay? So angle, side angle, meaning we need to have the angles between the 2 sides, or sorry, the side between the 2 angles. There's the angle, there's the side, so it's got to be this angle, and it's got to be this angle. So we need to know that angle M is congruent to angle D to get angle, side, angle. All right, angle, angle, side. So where's the side? Here, because of the reflexive property, right? So we know that. Now we need to have 2 angles. Well, this is opposite the single arc, and this is opposite the single arc. So it turns out you have choices. Could you say that this angle is congruent to this angle? Would that get it? Yes. So could you say that this angle here, whatever angle that is congruent to that angle? You could. In other words, you could say that angle G and M, G and M, in this case you have to use 3 letters, you don't have any choice, is congruent to angle L and M. That's one way, right? What's another way, though? So if you take a look at this, what if it wasn't this angle? What if it was this angle and this angle? Would that work? Angle, angle, side, angle, angle, side. This side is still opposite the 1 arc on both triangles and next to the 2 arc, right? It just means that the triangles are kind of in a different orientation. They're still congruent. So this is one possibility if it was this angle up here. The other possibility would be that you could say angle G and M, right? This one up here is congruent to angle NML. Either case would work, okay? So angle, side, angle. We get this angle because of vertical angles, right? They're congruent. So what we need is the angle such that this side is between. So in this case, we don't have a choice like we did the last triangle. It's got to be angle T congruent to angle Y. A lot of the time you're going to have some choice with angle, angle, side, depending on how it's made up, right? So angle, angle, side. So here's our side that's shared automatically. That's because of the reflexive property, right? So now what? It's got to be the angle that, so we can't pick this angle. That's not an option. We could pick this angle and this angle because it has to be not between. So the side has to be not between. So it must be angle Q congruent to angle A. So in this case, we don't have a choice. Yay, no choices, right? Okay. This is congruent to itself. QR is congruent to QR because of, well, the reflexive property, again. And now what? Angle, angle, side. Angle, angle, side. Angle, angle, side. This drawing and this drawing here, if you look at it, they're basically the same. Just slightly different shapes, but it's basically the same. So you do have choices again. Now I'm just going to list off one. Let's say we want to go with this being congruent to that. So we could say angle URQ, URQ. Vertex always at the center is congruent to angle PRQ, PRQ. That would get us angle, angle, side. Obviously, there are a couple other choices here too, though. Okay, angle, side, angle. Well, we get this angle because they are vertical angles. Remember, you can use the drawing against itself, which means we need to add the side between, which must be this side and this side, which means GH congruent to HL. Right? Here's another reflexive property. Notice how I'm just doing this before I even take a look at this. Oh, it's angle, side, angle. So it must be these angles here because those are the only angles that would make that side between them. Oh no, I have to use 3 letters, the horror. How about TFG? TFG. That didn't work as a G. TFG congruent to angle HFG. So there are some examples of how you can decide if, based on the information, the two triangles are congruent, or what information you need to add to get angle, angle, side, or angle, side, angle congruence.